This is lab 1. We're gonna start from .data. We have declared a variable total as the word, and we give it value 0. Here on autos we can see the verbs that are used, and in the memory we can locate the address of the variable. So here first of all we're gonna add a variable total in watch. After that we're gonna do a step over. So let's make it in hexadecimal first. Oh, it's in hexadecimal. So after we do a step over, the EAX has been initialized as 123 hexadecimal, as we can see here, and as we can see here also. So we're gonna do step over again. We have been added 56700 hexadecimal to EAX. Here we're gonna locate the address of the total. After we do a step over, the EAX has been subtracted 777.00 hexadecimal. After we do a step over again, as we can see, the value of EAX has been moved to total. And that's all for lab 1. So now we're gonna start with part B. We have value 1, 2, 3 as 10,000, 40,000, and 20,000. And we have added them on watch 1, and the value of EX, as we can see here. So let's start with the step over. So after we step over, the value of EX has become 10,000. Now I have forgot to add final val. So the value of final val is 0. So after we make a step over, the value of EX has become 10,000. We're gonna step over again. We have added 40,000 to EAX, which has become 50,000. Step over again. We have been subtracted 20,000 from EAX, and it's become 30,000. Let's look at the location of val 1. As we can see here, it's the location of value 1. So after we make the last step over, the final value will become 30,000. And that's all for part B.
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Adam Shahmi. So for lab 1, I'm going to explain about part C, which is the add and subtract. So this is the circle from the lab manual, as you can see here. And first and foremost, the first thing that we need to do is we need to rebuild it first. So rebuild solution, and it will take a couple of minutes per second. And here in the output windows, you can see that one succeed, zero fail, and zero skip. It means that our source code got no errors, so we can proceed with the debug. So debug, we just first and foremost we just start without debugging. And then we do start over, or we can just press F10. So they are going to pop up the execute windows. Just ignore that for a while. And then this one just do this assembly. And then this is the this is wait a second. We need to okay. So this is the first windows that we need to open, which is the first one is disassembly, and then registers, autos, memory, and watch. So for the memory, when we look at the source code, the first variable is vol w1. So we need to look for the vol w1 address. So ampersand vol w1. So this is the address for vol w1, which is 00db6000. This one is 1000 is vol w1. It is actually backwards. And then for the watch, we need to list out the variable that we have. Define in vol w1, vol w2, vol w3, final vol w, vol b1, vol b2, vol b3, and final vol b3, final vol b. And this is the value that we have for each variable. And then we just press F10 for each line. So right now we are at here main prop. So F10. So F10. So in line 19, we are going to move AX to vol w1. It means that we are going to set AX with value of vol w1. What is vol w1? Vol w1 is 1000. So we press F10 again. So right now AX is 1000. And then in line 20, we are going to add vol w2 to AX, which is 1000 with vol w2 values, which is 4000. Basically, it's going to get 5000. So we press F10, and then we got 5000 for AX. And then for line 21, we are going to subtract AX with vol w3, which is 2000. And then basically, we are going to get the new AX value is 3000. And then for line 22, we are going to set final vol w with AX, and this one is to store the results. So we're going to store 3000 to final vol w, which is right now is 0000. So we can see here, it is actually final vol w right now has a value of 3000. And then when we want to in line 23, we want to call the drum register. We want to display the register. So if we press F10, we can see in the execute windows, this is the registers. It's already been printed out. And then for the line 24, we want to move AH with vol B1 values, which is 10. And you can see here, vol B1 is 10. So when we set AH to vol B1, look at here, AH right now is 10, 10, and then we want to add AH with vol B2. Vol B2 is 40. It is now in byte. So you can see when we press F10, we're going to get 50. And then in line 26, we want to subtract a H with val B3. Then we're going to get a H with the value of 30. And then in line 27, we want to move final val B with a H. We want to store the result. So we press F10 and we got final val B 30 with 30. And then we want to call the register. We want to display register. Just press F10. And we can look at the execute file. That is another type of the register. And I think that's all from us. Thank you.